Hello everyone, my name is Reena and I am here with my group members Arshpreet, Mark, and Harnoor, and we will be doing our project on NLTK, text summarization. So an introduction to NLTK. So NLTK, as we learned in this course, is a leading platform for building Python projects that work with human language data. It has interfaces that are simplistic and easy to use, as well as many text processing libraries for classification, tokenization, stemming, parsing, and many more things. And here's about our project. So we chose to do our project on NLTK text summarization. As we mentioned before, our project is a text summarization script that is able to summarize Wikipedia articles based on the frequency that certain words occur. It will then print the top sentences in a paragraph format while also showing a plot of the most frequent words and characters that are used in the article. So in our project, we work with Python 3.9.5 on the idle. We use libraries Beautiful Soup for, XML, and Corpus.
So these are the libraries and packages that we use in our project. So we will mainly focus on the usage of NLTK here since our project is mostly on the text analyzation or summarization. So we also installed some of the libraries here in order to make our project more functional, flexible, and to deliver all the requirements. So for the usages of the libraries and packages, for the URL lib that request, we use the URL open function in order to open our source URL, and then we are assigning it to the script data variable. And then for Beautiful Soup and LXML usage, since we already have the source open, we now read it through the read function of the Python and store it in variable article. So after that, we parse in the article through Beautiful Soup. And by default, Beautiful Soup for parse documents as HTML. So we also pass in a second argument XML from LXML module to convert it to XML. So now that we have the XML, we use the find all function from the S4 to get all the p tags and get those values. So we also created here an empty string to hold the values collected here in the parags. So also we have here the stop words from nltk.corpus to in order to ignore the words that doesn't add much meaning to the collection of our sentences.
Hi, I am Harnoor Kaur and I will start with the pre-processing of data. The first step is to remove references from the article. The script shown on the screen replaces the resulting multiple spaces by a single space. The collecting underscore text contains text without brackets. So we will not remove other number, punctuation marks, and special characters from the text since we will use this text to create summaries, and weighted word frequencies will be replaced in this article. Next, we will clean the text and calculate the weighted frequency. For this, we will create another object that is formatted underscore article underscore text. So now we have two objects. The article underscore text contains the original article and the formatted article text will contain the formatted article. So now we will use the formatted article text to create the weighted frequency for the words and will be replaced by the weighted frequency in the word with the words in the article text object. Moving ahead, now we will do the tokenization. This is converting the text into sentences. At this point, we have already pre-processed the data and now we need to tokenize the article into sentences. The script that is presented on the screen shows the tokenization. Moving ahead, we will now calculate the weighted frequency of occurrence of each word. We will use the formatted article text variable. The script shown on the screen shows how we calculated the weighted frequency. Now first we will store all the English stop words from NLTK library to stop word variable. Then we will loop them all in all the sentences and will check if they are stop words. If not, we will proceed to check whether the word exists in the word underscore frequency dictionary. If the word is encountered for the first time, it is added to the dictionary as a key and its value is set to 1. Otherwise, if the word previously exists in the dictionary, its value is simply updated by 1. To find the weighted frequency, we simply divide the number of occurrences of all the words by the frequency of the most occurring word.
So for the sentence scores, we also initialize a dictionary and assign to this variable. So basically, the code will just loop through each of the words from the previous results array and check the number of its occurrences. So after getting results from previous codes, we now plot those using the matplotlib. So matplotlib is widely used to analyze data statistically. And lastly, for the heap queue, we use here the nlargest function in order to get the top 7 sentences that has the most number of elements, and then we print it.
Finally, we have reached the conclusion of the project. So to conclude, this project is an application of NLTK with the use of Python libraries and packages. It allows us to convert longer text into summaries. A user can paste the text into the application and within few seconds, it gets converted into a short summary. This technique splits the paragraph into sentences wherever a period is encountered. After that, all the special characters are removed. We have also demonstrated a summarization of a Wikipedia article.
Hello, my name is Reena, and I'm with my group members Arshpreet, Harnoor, and Mark, and we are doing text summarization with NLTK, and we are group 4. So for our project, the goal is to text summarize any Wikipedia page and output a summary to the user. Here are the sources that we use at the top in the script, and here's our names and numbers, and here's the libraries that we used, and here's the code that does all the data processing, the tokenization, and uses the libraries to sort out the words into sentences. And we also do weighted frequencies over here, and so on. So now I will do a run of the project. So first it will output a plot graph about the most used words and characters in the article. So you can see that these punctuations and words are the most used in the whole article. And when we close this, it will also process the summary in a paragraph format right here. Like this. You can do it with another article as well. Reference, we have another movie here, track movie. So when we run this, you can see that's slightly different words that we get here, and they're more frequent. When we close this, we get another summary of that article. Here. Okay. Thank you for listening to our demo.